Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun word problem, and here it is. So we have a basketball player that shot below 75%, and then that was early in the season, and at some later point in the season, that same basketball player was shooting over 75%. So the question is, was the player ever shooting exactly 75%? So if this is a question like this, then I assume that it's either always true or it's never true. So let's kind of look at some examples. Let's say at some point in the season, I shot one half of my shot. So maybe I just shot two shots and I made one. In order to get above 3/4, we got to add one. So we're still 2/3. That's still less. And now if I add one again, I hit 3/4. So what do you know? In order to get over 75%, I had to hit 3/4. So what happens if I had, let's say, 3/5 shot? So I've shot 5 and I've made 3. So in order to get over 75%, so let's look at this. So my next shot, it goes in. Now I'm at 4 out of 6, still less than 75%. Then I get up to 5/7. That's still less than 75%. And what do you know? I've now hit 6 out of 8 shots, and I had to hit 75% in order to get above 75%. So it's kind of weird, but is this always true? Is there some mathematical reason why this always has to be true? Let's go ahead and check it out. So first, let's define some variables. Let's say M is the number of makes. So these are the shots that go in the basket. And let's say that T is the number of total shots. Okay, so I'm shooting T total shots and I'm making M shots. So in order for us to be less than 75% at the beginning of the season, what we're saying is that M divided by T is less than 75%, which is 3 out of 4. Okay, so M over T is less than 3/4. And I could rewrite this pretty simply as 4M is less than 3T. And what do we know about M and T? So we know both of these guys have to be integers. I can't take half of a shot. I can't make half of a shot. So it either goes in or it doesn't go in, and I either took it or I didn't. So it has to be a whole number. Okay, so if it's, let's say it's not true. So let's say it doesn't have to hit exactly 75%. Then what does that mean? So that means that, let's say that I had, my M over T was less than 3/4. At some point, if I don't hit that 75%, there has to be an M and a T such that the next M and T, so if I take one more shot and it's a make, we'll call that M plus 1 over T plus 1. Sorry. That means that that next shot has to be greater than 75%, which we already said was 3/4. Okay, so what am I saying here? So that means that 4M plus 1 is greater than 3T plus 1. And I can go ahead and distribute that. We get 4M plus 4 is greater than 3T plus 3. And I can write that as 4M is greater than 3T minus 1. All right, but we have something interesting here. So I have 4M here, and I have 4M here. So what I've just said is that if I kind of reorder this, I have 3T minus 1. That's coming from right over here. We're saying that's less than 4M. And that 4M is less, once again, than 3T. So I have 4M is less than 3T, but it's also greater than 3T minus 1. So I want to highlight something we noticed earlier. So we said both of these guys are integers, right? So that means if I take a multiple of them, it's also an integer. So that means that 3T is an integer. 3T is an integer, and 3T minus 1 is also an integer. And they're not only integers, but they're also consecutive integers. So 3t minus 1 is going to be exactly equal to 3t minus 1. So they're consecutive. So let's say if t was 7, then 3t minus 1 is 20, and 3t is 21. So they're consecutive integers, and what that means is that this number, 4m, cannot be between 3t minus 1 and 3t. There does not exist a 4m. So my premise was false. So what was my premise? My premise was that this statement is true and this statement is true. And if that's false, it means that that's not the case, and it must be that I have to hit exactly 75% in order to go from below to above. And that's this quick little problem. So I hope you enjoyed working through this with me. If you did, please like and subscribe, and have a great day.